So hello everyone, welcome back to Algo Daily. In this particular video, we are discussing LeetCode daily problem of the day, design a number of container system. And in this problem, we have to given a number container with their system and their following operation: insert, replace a number at the given index in the system, and we have to return the smallest index for the given number in the system. And now we have to implement the number container class, and this is number container class. And this class we have to given a number container with this is initialized with the number container system. And now one function we have to given a void change function, and which is in index, and number is storing here, and this fills the container at index with the number, and if there is already a number at the index, we have to replace it. And now second is if int find function. Int finder function is contain a number where we have to return the smallest index for the given number, or -1 if there is no index that is filled by the number in the system. And now here we have to give an example test cases. And now let's look at the example test cases, then we have to look their coding implementation part, how we achieve a brute force to optimize solution. So here we have to design a number of container system that supports the following operations. Like operations is, first we have their operation is insert operation, and second is our replace operation. And the insert and replace operation, we have their change function, and this change function, void change function, is contain an index and a number, and store a given number at a specific index. It means store a given number, like given number and at a specific index. Okay. And the second thing is if an index already has a number, we have to replace it with the new number. And this find function, and this find function is generally given a number, return the smallest index where that number is stored, and if the number is not found, we have to return -1, and if number is found here, and then we have to return number. And now our goal is to find the effectively insert or replace the number at specific index. Like you have given indexes, and you have to insert it like here and here and here and so on, and you have to insert it accordingly. And then effectively we have to find the smallest index containing a given number. And last thing, we have to optimize our solution. Okay. And optimizing our solution, we have their constraint also given here, and the constraint are 1 less than is equal to index, number less than is equal to 10 to the power 9. It means we have to given specific values, and their specific index contain where the number is stored. And first we have their large range, we have to give a large range, so that array is insufficient. Like if we have to track with their array values, and array is taking by step, like index wise we have to checking with their values, and this is taking too much time. Okay, so that at most 10 to the power 5 operation we have to perform. Like at most 10 to the power 5 operation means O of n solution is also be slow here. Like when we have to iterate all over the values, like index by index we have to check. Okay, index by index we have to check, it is too slow. Like we have not storing the previous values, and we have to jump again and again our previous values, next values, and so on things. Like so we need to iterate our solution of O of log n solution, or you can say O of 1 solution. Okay, and you can use the effective data structure use, like map we have to use, unordered map we have to use here for lookups. Like uh, how actually we have to look their next values and their previous values. Okay, which already iterated. And one second thing, we have to use set, and this set is storing the index in sorted order. Okay, storing the index in sorted order of O of log n iteration, and this iteration O of log n is taking insertion, and second is deletion, and all operation is performing in set is O of log n iteration. So now let's look at their example test cases so that you can understand how actually we have to work with their input test cases. Then we have to find their output. And now first we have their, and first we have given a number of containers, and here we have find and change and change and change and so on things. We have to given the container function, like how your operation, how the actually operation you have to perform here. And now the number container, we have their first, we have their initial state, like the brute force we have to discuss later on. And first we have to discuss the initial state, like we have to create a map. Okay, and the second, this map, we have to create map of int comma int, and this mp. And second thing is we have to map of set. Okay, and this map of set is m, and this mp is initial state is empty, and this m is also be an empty state, and this is output is null. Okay, and this is our state 1. And the second state, we have there find what we have to find, we have to find 10. And now we have there calling this function of find, because we have to given here find, and then second we have to given change, and again change, again change, and here find, so that we have to find accordingly. So here first we have to given find, and we have to find 10. So no any index contains 10 value, so output is -1. Okay, and the third is we have change function, we have to calculate perform here, sorry. So change is 2 comma 10, and this 2 comma 10 we have to insert 10 at index 2. And so we have to insert it like mp of 2 to 10, like we, this is our key and this is our value. We have to create a key value pair functions here, and we have to iterate all over the values by using this key value. And now we have there m become 10, and this like 10, and this 2. Okay, and now we have their output is null. And the fourth iteration, we have their in fourth iteration we have their this change function again, and here what we have to do here 1 comma 10, the change, and this 1 comma 10, and this 1 comma 10 we have to insert 10 at index 1. Okay, this 10 index 1, and this mp is now we have to get to 10, because we already added 2 10 and 1 1 and 10. New value is here 1 comma 1 to 10. And now this m is become 10, which index we have to getting here 1 and 2, this 2 and this 1. And now fifth iteration, and this also will become null. And the fifth iteration we have there 310, and 310 also be here change, and 310, and this 310 we have there 10 insert 10 at index 3, and this mp of 210 comma 110 comma 310, because of 210 we already iterate, 110 we already iterate, and this 310 is now occur here. And now the m is this mp this map of set is here now this 10, and which indexes 1 2 and 3. Okay, and now output is null. And the sixth is the sixth iteration we have follow here, like 310 is already computed, and now here is 510, and this 510 is also be a change change here, like you can say This 510 is also we changes here like 510. Okay, and now this 510 we have MP of 210, 110, 310, and now what we have to get 5 and 10, and this M is equal to this 10 is which indexes we have to get here, 1, 2, 3 and 5, 1, 2, 3 and 5. And now the seventh iteration, this iteration is 10, and now this 10 we have to find here. Okay, this 10 we have operation is find, and this 10 we have to find like which indexes we have to calculate it here. M of 10 is where we have to find this one, 1, 2, 3 and 5, 1, 2, 3 and 5. And now we have to find minimum, smallest minimum index. Smallest minimum is equal to 1, this one. Okay, and the eighth iteration we have 110, sorry 120, and we have their change function calling, and this 120 and we have to change, and this 120 we have their uh, MP value is, and this 120 is like we have their remove one, this one index we already present 10, so we have to remove this 110. Okay, this 110 we have to remove. Now we have to insert 20 here. Like what we have to get here, we have to get, and we have to add this 1 and 20. Okay, and so now we have to get 210, 120, 310 and 510, and now our map of set is become 10, where which index we have their 10 value, 2, 3 and 5, and the 20 is this 20 is one index. This is our set value. And now the ninth iteration, we have their 10, and this 10 we have to find here, this 10 we have to find here. And now this 10 where the 10 is present, this second, third and fifth index, so now what we have to get, we have to find the smallest index. Smallest index is here 2, so we have their output is equal to 2, and here, so now what we have to get here, first we have their null, and this null, and the second -1 because no index is found here, and again null, and this null. Okay, and then we have there also here will be null, and this here 1, null and 1, and then here we have no any changes, so null, and this is 2. Okay, null comma 2. So what we have to get, null -1, you can see null -1, null -1, null, and then 1, null and 2. So I hope you understand how actually we have to match the exact result to our given output. And what we have to do, first we have to initialize with all the values with null, and then we have to find here all values we have to find. Then if the change function is occur, then we have to find minimum index, which minimum index we have to calculate it here. Okay, so I hope you understand the example test case part, like we have to iterate with their map and this set value. And now let's look at their brute force solution, like when we have to use brute force, then what the condition is. Like in brute force, we have to use a map of int comma int, and this map is only iterate a index and the number value, and the number value, and then we have to iterate. If the number value and this number value and it dot second value is same, then we have to return it dot first, else we have to return -1. Like it takes O of n time, because we have to iterate one for loop, and this one for loop we have to find the function, and we have to call a find function. Then it takes O of n time, and we have to iterate all over the map, and this fails the large constraint of uh, this value, and this becomes very slow, and this gives a TLE solution. And now let's look at their optimized approach, and this is our optimized solution. And first we have their unordered map of map and unordered map of set with M, and this map of we have their index to number, and this one is our map of number of set of indices. Okay, and then we have their change function, and here we have to get the old number at the index, and then we have their map of index is equal to number. Here we have to update with a new number. Okay, we have already discussed here, like we have to update with new number, and you can say once again here we have to change with 1 to 10. 1 to 10 is already present, but here we have occur 1 comma 20, so that we have to replace 1 to 20 with 1 to 10. Okay, and then we have their here we have their M of temp dot erase of index. Here we have remove old index from the previous number of our set, and if the set is already empty, we have to insert the index into the new number set. Okay, and then this is our change function. It is a simple function. We have to iterate with their previous old number, then after old number we have to update the number, and then we have to remove old index. Then if the set is empty, then we have to insert into the new number set, and then we have to find all and we have to change all these values. And then this find function, we have there return the smallest index here, like if the it is equal to mp dot m dot end, and if it is true, then we have to return -1. Then we have to find this minimum number, smallest index. And also the one second and also we have their time complexity of this code is, and this time complexity of this code is we have to check the number of found and not found, and this become O of one time. And this O of log n solution, if the number is found, since set dot begin, and you can say set dot begin and all these stuffs, so we have to calculate with O of n log n solution, and you can say the change function, the change of index comma number change is equal to index comma number. It becomes it is taking O of log n solution, and also the find function is taking O of n or O of log n solution, like O of 1 if not found. If found, then we have to check with their possible index. Okay, so we have to iterate here. So the total time complexity of this code is O of log n, and then it is enough for this iteration. Okay, and this unordered map is provide a fast lookups for our previous value and next values, and the set keeps the indices the sorted accordingly. And the summary is basically we have to use unordered map and unordered map for fast number computations, and then we have to use their set, and this set is keep the indices is sorted, and then we have to optimize our solution by using this one. And so I hope you understand the logic and the implementation part of this code, like how actually we have to implement our output, like this one. First we have to use a null value, and then we have to find their function, and using this function we have to check their values, and which operation we have to perform we have to already given here. So thank you everyone, thank you so much.